Hey guys, this is an example of multiple linear regression modeling, and we will look into how to go about doing that. The problem is about serial data that provides variety of nutritional information for about 67 cereals and their shelf location in a supermarket. We need to use regression analysis to find the best model that explains the relationship between calories. So calories will be our Y variable or dependent variable and other variables, which will be the independent X variables, and investigate the model assumptions and clearly explain the conclusion. So here is what the data has got. It's got 67 cereals from 1 to 67, the name, manufacturer, but here are the calories, which are Y. This will be our Y variable, and carbs, sugars, fiber, and sodium, that would be our x1, x2, x3, x4. So we have four independent variables and of course one response variable. So uh, this is what the solution would look like, and we will look into how to go about arriving here. So certainly we will go to data tab and look into data analysis and select regression from the menu and hit OK. And we will put calories as the Y variable. We will put the four X's, which are carbs, sugars, fiber, and sodium, as X variables. We will highlight labels because we have labels on the first row. We will get an output, and immediately we get the output here. So this is the first output. From that, let's move to the final solution here to look into the step-by-step solution. This is the same first output that we have gotten when we run regression analysis, and as you will see in this output, the R square and the multiple R and an ANOVA table saying that it is significant to do a model because significance of S is smaller than the critical value. Therefore, it is okay to do a regression model. In the regression model, one of the independent variables has a coefficient that is statistically equal to 0. And how would we know that? Because the p-value is large and is larger than the the t statistic. Therefore, this coefficient is actually virtually 0 and does not impact the modeling. So we will have to eliminate the fiber as a variable and come back and regenerate the model. The way to do that is the exact same way we started. We will do data analysis, regression. This will stay the same, but our independent variables will change because we will need to take the fiber out. So we will put these two. Let's see if it'll let us do 2 and 1. And hit the control button and add this one as well. So this way we highlighted 3 independent variables and we dropped fibers or fiber and hit OK. Okay, it's asking us to input the range altogether. So in this case, we will cancel out and we will delete this fiber column, and again go back to data analysis, regression, and now we will highlight all 3 together as X variables. We hit OK. There we go. We get another output from Excel as regression table, which here will be the second output here. As you see, the fibers are gone. We have 3 independent variables for the model. But when we investigate what the model looks like, we will find that the sodium coefficient is statistically equal to 0. And why we say that? Because the p-value is less than 0.05. I mean, it's larger than 0.05. In this case, we need to eliminate sodium as well. So we will go back and eliminate sodium and rework the problem. So delete sodium, data analysis, regression. This is how you fine-tune the regression modeling, because you want coefficients that are solid and they have a value statistically different from 0. So if any coefficient is statistically equal to 0, we need to eliminate that to have a viable model. In the independent variables, we will change that. We'll keep that as is, as y variable. We'll change the x's into 2 instead of 4 now. We had 4, now then 3, and then now 2. And hit OK. We get another output, and this output, even here, if we look at the p-value or go back to the solution, this is the third attempt, and we call that the best model. Why is that? Because carbs and sugar coefficients are very significant and the p-value is very small, and it's less than 0.05. Therefore, these are significant coefficients, and that will be our best model. Model and the parameters are significant, which, as you see here, the intercept as well. The variability explains why the model is high, because the adjusted R-square is about 71%, which means 71% of the time the variation in calories can be explained by carbs and sugars. And that will be the best model that we need to go by to predict calories in the as we change carbs and sugars, see how that impacts the value of calories. Thank you.